A very warm welcome to this, the first film in our Fitting Out Floors and Ceilings series. In it, we look at some of the key characteristics of floors and ceilings. You already know that load-bearing floors and ceilings can either be solid or of a beam-type construction. Solid floors consist of a uniformly thick reinforced concrete slab, while beam-type floors are made using a combination of beams with boards laid across them. Beam-type floors can be built in reinforced concrete, steel, or wood. Floors and ceilings located between areas that will be used for different purposes need to reduce the transmission of noise. There are two different types of noise. Airborne noise propagates through the air, while structure-borne noise is transmitted through the structure of a building in the form of vibrations. The propagation of airborne noise is countered using a high-density material that does not vibrate under the influence of airborne noise. In buildings, this is generally provided between stories in the form of a sufficiently thick reinforced concrete floor. Structure-borne noise occurs not only when airborne noise hits a solid object, but also when the structure in question is made to vibrate. A simple example is knocking at a door. In building, impact noise is also important. Impact noise is the noise generated by walking on a floor or stairs. Its propagation is prevented by decoupling the floor covering from the solid floor slab beneath it using a soft, sound-absorbing intermediate layer. Airborne noise causes walls, floors, and ceilings to vibrate, but these surfaces also reflect airborne noise. Hard surfaces are strong reflectors of sound, whereas soft surfaces like the foam panels you can see on the right here absorb sound and reduce the amount of reflection. It's the properties of the surface material that determine how much sound is reflected. A high level of reflection causes a high degree of reverberation and can enhance the music listening experience, for example, whereas low levels of reflection create a dull sound that is sometimes described as dry. Floors need to be safe and comfortable to walk on. Particular attention is paid to the anti-slip properties of floors on which people may need to run, as in Dresden Schulz fire station here, for example. The rougher a surface, the more non-slip it will be. However, it will also get dirty more quickly, which results in more frequent cleaning and also causes a temporary reduction in non-slip safety. Ceilings also have to be able to accommodate various types of building plant and services. These two photographs show specialist laboratories that are full of technical equipment. In our Karlsruhe project on the left, all the services are visible. In our specialist laboratory in Leipzig, on the other hand, they are concealed in a suspended ceiling and within the walls. Ceilings can also play a part in ensuring that building interiors are comfortable in the summer by helping to maintain pleasant temperature and air humidity levels. Solid slabs are able to store heat through the day and release it again at night when temperatures are cooler. This works with a bare concrete floor, but not if the floor is concealed by a suspended ceiling, for example, when the air is prevented from transmitting its heat to the concrete. In some cases, floors also need to be watertight to prevent the ingress of water into the fabric of the building. It goes without saying that this swimming pool in our Munich school project had to keep the water in, but a shower in a residential house also has to be watertight if water is not to penetrate the floor. Floors and ceilings play a large part in the design and atmosphere of a room. If a room is to have a high-quality interior, then the floor and ceiling must be attractive and well-matched. Summary: load-bearing floors and ceilings can be solid or of a beam-type construction. Floors and ceilings located between areas that will be used for different purposes need to reduce the transmission of both structure and airborne noise. The propagation of structure-borne noise is prevented by decoupling the floor covering from the solid floor slab with a soft, sound-absorbing intermediate layer. Airborne noise causes walls, floors, and ceilings to vibrate, but these surfaces also reflect airborne noise. This reflection can be reduced by the use of soft surfaces. Floors and ceilings may also need to meet other requirements depending on their position. Our Fitting Out Floors and Ceilings series continues with film number 2, in which we explain what the term fit out means.